Welcome back to Tronics Energy. So in the previous videos we have been doing a lot on registers and trying to understand the different types of registers which are out there and their operation. And in a couple of videos we've been dealing our circuitry or building our circuits using the 74LS195 IC, which we said is a general purpose IC. So I did a serial input, serial output, parallel input, parallel output, serial input, parallel output, and the last configuration was a parallel input, serial output, which after many attempts, I didn't succeed on making that using this IC. It's quite hard to configure this or to manipulate this IC to give you a parallel input, serial output. So I decided that I'm going just to go and look for an IC responsible for a parallel serial input, a parallel input, serial output configuration. So for now I'm going to halt the videos on registers, and we're going to do another video which is much useful, and I've seen many people are asking me to do the video. So for this one I'm going to halt, but when I make the parallel input, serial output, I'm going to share it with you guys for you to understand. I'm going to put it on the playlist which we have on registers. So today I want us to understand more about an NE555 in Astable mode. So I know I did a video back then, some few months ago, on how an NE555 can be connected to give you an Astable output. And I remember that I didn't quite explain what really happens inside, or explain quite deeply for you to understand. So today I'm going to attempt to explain how this IC and NE555 does its operation to give you Astable or an oscillating square wave output. So this is the internal schematic of the NE555, and you can remember it has the pins: pin number 1 ground, pin number 2 trigger, pin number 3 is the output, pin number 4 is the reset of this flip-flop, pin number 5 is the control voltage, pin number 6 the threshold, 7 discharge, and 8 finally VCC. So this is the internal schematic of the IC. This is how it looks inside. I've demarcated it using these dotted lines right there. So the external circuitry you're seeing here is how you can connect an Astable. You can connect an NE555 to give you in an Astable, to operate in an Astable manner. So the circuitry consists of a capacitor, which kind of depends on you or what you want, or how you want your pulses, your square wave to be, the frequency of your square wave in the output, and two resistors which are mostly identical. And yeah, those are just what you need in order to make an NE555 operate in oscillator mode. So I'm going to explain deeply what happens for you to understand, and so that we can continue well. And later on I'm going to demonstrate it. This is a circuit. I'm going to demonstrate it, and yeah, it will be better. You'll understand, you'll have understood what happens inside the NE555 timer. So when the capacitor is charging, once you turn on this VCC, when the capacitor is charging, the voltage here is low. The voltage here, you can see the trigger pin and the threshold pin are connected together. So the voltage here is low. This, when it's low, if you can remember this part, which is I've called it B and part A. So for part A, the voltage there is 2/3 of VCC. 2/3 VCC, and for the B part, the voltage there is 1/3 VCC. 1/3 VCC. So if let's say I'm working with maybe let's say 9 volts. If I'm working with 9 volts, meaning that this part will have a 6 volts, and this part will have a 3. It's 3 volts. Yes, that is if I'm working with 9 volts VCC. Yes. So once I'm charging, the voltage here is low. It's lower than 2/3 VCC, meaning that when it's low, it's going to activate this comparator. So the comparator here will give a 1. That 1 will enter this set, part of this flip-flop. Once it has enters the set, Q bar, which is the opposite of this set, is going to give you a 0. Is the inverted of this, so it's going to give you a 0. And this part of the circuit, the comparator 1 right there, because the voltage is lower than even 1/3, then this comparator is not going to give any output, so it's going to give you a 0 output. So nothing really happens, nothing really changes on our RS flip-flop. So this 0 comes in, enters this inverter, and the output here will be 1. Output will be 1 because the 0 is inverted to be 1. The 0 also, you can see this part of the circuit is connected to the discharge pin number 7, and is connected to the other circuitry. If you check this circuitry very well, I'm charging the capacitor via these two resistors. So if this is on, if this part, if the discharge is on, it means that we are discharging the capacitor. The capacitor is actually discharging. But if it's off, like for in our case, it's off because the base of this transistor is not activated yet, it means that the voltage is just coming and charging my capacitor. So in the next stage, the capacitor has charged to 1/3 VCC. If it charges to 1/3 VCC, it means that this part of the circuit will be 0, because okay, this part of the circuit, this part of the circuit will be 0, because this trigger is more than 1/3 of VCC. It means that it's going to give a 0. But nothing is going to change, because the 1/3 is not big enough than the 2/3 right here connected to the inverting input of this comparator. So it means that nothing is going to change in our RS flip-flop, and the capacitor will continue to charge. In the last case, the capacitor has now charged to more than 2/3 VCC. If it is for more than 2/3 VCC and it enters the non-inverting input of the comparator right here, it means that this one is going to give you a 1. When this one gives you a 1, then it's going to give a 1 output on the Q bar. Once the Q bar is 1, the output here will be 0. Output will be 0, and that 1 is going to enter this base of this transistor. Entering this base is activating this NPN transistor, meaning that we are going to discharge our capacitor. It's going to discharge until it goes back. It goes back to the initial state. Once it goes back to the initial state, then this comparator is going to give you a 0, and the trigger right here is going to give the trigger comparator right here is going to give you a 1, because the capacitor has now discharged lower than 1/3. It's going to go lower than 1/3 of VCC, and that cycle continues. So it charges and discharges. That's basically what the circuit does. And right here is going to give you a square wave of that sort. So it's going to give you a square wave output. So that's basically what happens inside the NE555 circuitry to give you an oscillating pulse at the output pin number 3. So I hope you've really understood how the NE555 works inside. So the NE555 circuit is just right, it's right here. You can see. So this NE555 has a very big capacitor right here. If I can, let me just use a small capacitor, small one right there. Yes, it's an 100 microfarad, still the same as this big one, only that this one has a much bigger rating in terms of voltage compared to this smaller one. Okay, so my circuit is right here. This is the outside circuitry, which is enabling our NE555 to operate in oscillator mode. You can see the two resistors, which are 5.6. I'm using a 5.6. You can see our capacitor right here, which will be charging and discharging, and the pins are right here. So the pins are right there. You can see pin number 2 right here connected to pin number 6 threshold, pin number 8 VCC, pin number 7 discharge is connected to the middle part, which is connected to the middle of those two resistors right there. We have right here we have the pin number 2, which goes to pin number 6, so meaning that we have connected them, and the pin number 1 is ground. And we have an LED connected to pin number 3 in order to see what's really happening in our IC. So I'm just going to power this, and we are going to check the operation. We are going to check the operation and what really happens inside. So let me just connect. It's not pretty hard. I hope you can see it's not pretty hard, just simple connection. So you can see the NE5 or the output is turning on and off, and just as we have said, the frequency of the output pulse is controlled by the circuit constants. The circuit constants are these resistors and capacitors, but most of the time we tend to manipulate them. We tend to change the capacitance rather than changing the resistance right there. So change the capacitors can change the speed quite easily. Like, let's say if I'm using a so these are 470 microfarad, which is much bigger than 100 microfarad. So what I expect is this capacitor, it takes a long time to charge, and at the same time it takes a long time to discharge, so much longer than what you can see in an 100 microfarad capacitor right there. So let's connect this. So the 470 is on. You can see it takes a long time to charge. Once it's full, it goes off, then it turns on. So this is much lower. You can see the pulse is on and off quite slowly as compared to the 100 microfarad. So that's basically how an NE555 can be connected in Astable, and that's how what happens inside the circuit. I hope you have understood what happens inside the circuitry. So it's much better. I would say it's much better understanding what really happens inside for you to better understand what you are making and what you are doing. No, it's not just connecting. Just try to understand what really happens. Try to be more curious in order for you to understand these operations quite well. So I hope you've really enjoyed the video, and next time I'm going to do a monostable and explain the internal circuitry. Then we are going to finish up making the bistable, and that will be it. So thank you very much guys for watching. Please subscribe to Tronic with Energy, and I hope to see you next time. Goodbye.